hello, everybody. How are you all doing today? Almost didn't make it today, honestly. Why? It's as hot as hell, and I had to help take care of my little brother as well. He was quite gassy today, so he woke up a few times, and I had to take care of him myself. Anyways, as per usual, I will start with my selling out speech. Down in the description below, you'll find a link to the Power Shop where you can purchase energy mixes, leap mixes, their hydration shakers, and stickers. And if you use my creator code Blackheart, you will get a 10% discount on your purchase. Okay, now that that's out of the way, and now I just need to wait for my friend Strange Bro Jim to finish up with his whole Pega stuff, of which I can see his stream right now, so I can keep an eye on it while he's finishes that up, and I'll know when he is on. Last time we went through a little bit of the meaty stuff. We didn't go through it all because, well, it needs some basic understanding of MIDI, and we don't know how to use MIDI at all. So we gave two native what's it called? Native sound feel ambisonics, and went through that. We did understand quite well, in my point of view, like directional sound and distance of the sound. This is more used for like home theaters when you have those five to seven speaker sets. This is where these sort of things would come into play. At least for the most part. I'm pretty sure this can be replicated through headsets as well. I mean, whenever I have played games where my characters look in one way, I can kind of tell from which direction the sound's coming from depending from which side of the headset I'm hearing the sound and how loud it is. And that's how I feel that this has been explained this entire time. Now, supposedly we didn't finish it. We still need to do the import and plain an ambisonic audio asset, sound feel submix, and sound feel encoding compatibility from that same like ambisonic stuff. We're probably gonna hop on into that, and hopefully we can understand what we're doing. I got Unreal open just in case we actually hop on into that and do something with it. And I see he's starting soon, so let me look for his stage right now and hop on into that. Let's see. There, his stage already open. Okay, now let's just wait for him. This sound stuff definitely is quite complicated, and there's still quite a bit to go through. I'm pretty sure there'll be other like audio related stuff we'll probably have to skip because of how advanced it is. Oh, and I just remembered, desktop is muted. There we go. From when he starts talking, you guys can hear him. When he starts talking, he's probably even doing some final setups or getting something to drink or something. And I'm also gonna put on the screen the
stuff. On this there, folks.
There he is.
1 second. Let me go ahead and get the Chrome set up here. There we go.
There he is.
And I see that Blackheart is available in the stage. Let me go ahead and invite him to speak.
Hello there, Jim. How you doing?
Not bad there, Blackheart. Not bad. I forgot my typical intro.
No problem, sir.
Oh, well, it's okay. Yeah, but hey, welcome everybody to our tutorial series for Unreal, or us trying to learn Unreal Engine. Uh, we're going through a lot of the topics that we feel are going to be necessary for us to build not only a clone, you know, directly afterwards, but, you know, our own games moving forward. So the first topic that you know we're covering right at this moment in time is the audio, which, as you can see, there's a lot. Um, so and here's the thing, we might be dealing with a lot more as we proceed onwards right at this point in time. Now, we haven't really had a need to go um, uh, like build anything like definitive yet. Using our examples here, maybe a little from time to time, but for the most part, not really. Oh wait, we did not get through all of the native sound field ambisonics, if I'm not mistaken, right?
No. No, we went to up to Ambisonics in Unreal Engine, and the next part was gonna be importing and playing an ambisonic audio asset. That
Right,
part we didn't have time to look over.
right. I was almost going on to the next session altogether. It's like, wait, no, we still have a little bit more left.
Yeah.
So, although from what I can see, or from, also from what I remember, we took a look at this upcoming section, and it's looking like it's fairly jam-packed with information, and hard to say whether or not we're going to be uh, understanding. Some of these topics we've come across, and we're like going, oh, okay, this is a little too much for us. Being that we're programmers, not sound engineers.
Nope.
Um, but we'll do what we can, or we'll have to probably put on those hats when the time comes. But for now, um, we can only do so much. So,
Yeah.
okay, shall we get started?
Yeah.
Okay. So, importing and playing an ambisonic audio asset. So, with the release of version 4.25, Unreal Engine only supports first-order ambisonic assets. Okay. How?
That doesn't tell
That,
us much.
yeah, it's like, okay, is there other orders? Well, whatever. We'll see. A first-order ambisonic asset has 4 channels: the Omni component, or W channel, and the vector components, or X, Y, and Z channels. Okay. Again, not really telling you too much, although, I mean, we're aware of um what was it again? It was the wasn't necessarily ambisonic. Um, they gave a word that I wasn't quite sure about before. I was wanted to kind of look it up, and I'm missing the word now. Ah, there it is. The azimuthal,
All right.
or azimuth. So, um, so if it's along those lines, or if it's kind of similar to that, then I can kind of understand the X, Y, and Z channels, and that it's kind of when you do X, Y, and Z, not only are you doing the horizontal and the vertical, and the, you know, you're talking about, uh, the X, like, maybe right in front of you, the Y off to your side, and then your Z is like up or down, right?
Yeah.
Um, you know, although in some graphic settings it's a little bit different than that. Sometimes it's like um, X is to your side, Z is right in front of you, and Y is the up and down. Whatever. It I've seen so many different combinations or differences of those that I'm never quite sure um, what people interpret from time to time.
Hmm.
So, um, so I can't say for 100%, what direction is, definitive, this is how you need to look at it. So, but I don't know what this Omni component would potentially be, you know.
No, I'm not sure myself.
So maybe maybe it has something to do with like the wave itself, maybe like the hertz or something. I don't know. Maybe they'll explain a little bit more later.
Hopefully.
Maybe. Okay, Unreal Engine supports two channel orders. FUMA or first Malham Ham and ACN Sonic's channel number. Okay. The FUMA channel ordering sequences the Sonic's audio channel components as W, Y, Z, and X. Okay. For what reason is my question on that, but maybe they'll explain later. We'll see. The ACN channel ordering uses WXYZ. So, and not sure why they have like the different orderings there, but
Maybe in the order from which they pick up the information, maybe?
um, maybe, or how they use the information. But
Yeah,
again,
like to determine where it is, where the audio is, maybe, since that's to me, so when you talk like X, Y, Z, it's sort of like a coordinate on a grid.
right. Um, yeah, but still, it's one of those things where it's like, why, what does it matter the ordering? What's the difference between the two? Um, which they haven't addressed,
No.
and we'll have to, maybe they will address it later on, and then again, maybe not. We'll see. Um, in first order, ambisonic audio uses 4 channels. Uh, any imported file that does not have 4 channels will be treated as a normal non-ambisonic audio asset. Okay. Um, and how does it, you know, what does it do for, hey, you're being treated because you only have 3 out of the 4 channels. Okay, how does it interpret that? You know, I don't know. Just one of the questions in my mind right at this moment in time.
Yeah.
Who knows if we're going to be getting an answer? So we move on. To import an ambisonic WAV file into the content browser, you should end the name of the asset with either underscore FUMA or underscore ambix. If your ambisonics file uses FUMA channel ordering, or your ambisonics file uses ACN channel ordering. This will tell the engine what the channel order of the original ambisonic asset is. After dragging your file into the content browser, when you open the Soundwave asset, you should see that The is ambisonics checkbox is already checked in the Soundwave Inspector panel. So just having those two tags at the very end of your file will automatically select
The order.
ambisonics, huh?
Yeah, the order of which ambisonic it's using.
Well, I mean, it just says like, hey, this is indeed an ambisonic just because you have those particular tags at the end. So that's interesting.
Yeah.
Um,
Yeah, that's not only there to tell it this is ambisonic, but also what order to give the information to that ambisonic.
sure. Seeing that they have the different orderings of WXYZ or WYZX. So yeah. Um, if you forget to enter the name of your file with MX or FUMA before you import the WAV file, you can still check this box yourself. The engine will assume that the original file you imported using ACN channel ordering if you do this. Oh, okay. So if you don't have like FUMA at the end of your file, for example, the engine will default to ACN, and there's really nothing that you can do about it
Yeah.
with that. So
Yeah, like adding those is more of a safe measure to ensure it uses the right order and not the default.
right, exactly. So after your ambisonic file is imported, you can treat it like any other sound file, a sound wave in the engine, with the important exception that rotation matters. When you play back an ambisonic sound wave via an audio component in the world, the engine will rotate the ambisonics bed based on the rotation between the current rotation of the audio component that is playing and the current rotation of the player in the game world. Okay. Engine will rotate the ambisonics bed based on the rotation. Rotate the ambisonics bed based on the rotation between the current rotation of the audio component that is playing. Rotation of the player in the game world.
Rotation of the player in the game will kind of makes sense to me because it depends. Okay, you're looking one way, you're gonna hear the sound in that direction. As for the rotational of the audio, that one is what?
Well, it in that case it might also make sense, like if you have like someone playing a loudspeaker, or someone like has like you know uh they have like music playing off their phone or something like that, and they're just kind of walking down the street, right? The speakers on their phone is kind of directed in in a certain direction, right? So
Yeah.
if it was like facing you, then you'd probably hear it a little bit clearer than if it was like facing away from you.
Yeah.
So there's that rotation as well.
It's like
Is it
directional sound, pretty much.
right? So is this covering that in this particular case?
Well, that's what making it sound like. If the sound's going this way and the player's facing in a specific direction, it's going to determine how you're going to hear the sound and which side you're going to hear it.
Right. But again, we come back to our original question as to, what is what the difference between FUMA and ACN? Why does it matter why you have different orderings? Um, what exactly is both of them differing from? Is there some form of mathematical computation that makes like FUMA over better than ACN? Is it something along the lines of like we don't care about typically W and Y for Fuma over the Z and X, so we don't really like it. You know, we get the W and Y, and we're pretty much happy. We don't need to worry about doing any kind of calculations with Z and X, and you know, there you
Um,
go.
the order is just to me it's just telling it the sounds in this location. As for the difference between one and the other, I think they're just expecting us to know a bit of sound engineering and how the particular softwares that work with this work actually differentiates from each other.
Well, that's my point though, is that they're not really addressing it themselves as to you know what the differences are, you know, here in this tutorial. You would think that yeah, it would be nice if they did, if they kind of gave you some clarification as to you know what is the purpose of these two channel orders, but they didn't, so it makes me kind of curious as to what that's all about. But again, you know, that's something that we may need to kind of worry about when we get to the point of adding audio into our, you know, into our clone and game
Mm,
later. But for right now, we probably could go ahead and skip it, I guess, for now.
yeah.
But it might be something very important later on down the road that, you know, it's like, hey guys, you know, it'd be nice to have a little bit more information along those lines, you know, on this page to know, you know, what is, uh, you know, these two orderings. You know, what is it all about? You know, does it even matter? You know, and if it doesn't even matter, then what's the purpose of even having these two channels? It's like, you know, you would think that um you know uh if it didn't really matter, you know, then there'd only be one channel ordering and that's it. You know, you wouldn't even need to really discuss it, you know, right?
Right.
So that's why it's like, you know, what's going on here? You know, what is the purpose of these two, and why are they different? That's it. That's my mentality right at this moment in time. You know, they wouldn't make those different orderings if there was some kind of purpose to it, but they're
Yeah, maybe
not
those
giving
orders
us
is
that
just
purpose.
determining what order it handles the sound.
Yeah, possibly. Again, you know, don't really know. Obviously, if anybody knows, you know, directly, like if you're a sound engineer, you've dealt with this before, you know, feel free to like leave a comment in our chats right now during stream, or you know, leave a comment on our videos as we upload them to our respective channels. So, you know, help us out with that. If you are aware, you know, it would be helpful. But we move on, shall we?
Yeah.
Alright. So, in addition to playing back ambisonic sound waves like you would any other sound wave, you can use ambisonics directly in the submix graph. To do this, you will need to create a sound field submix. Okay. Um, that's hmm, what exactly is a submix graph? Um, okay. Sound field submixes can be used and connected to other submixes in the submix graph, but are able to use any sound field representation currently implemented in the engine and implemented by a current enabled plugin. If you open your newly created sound field submix and look at the inspector panel, you will see a drop-down menu for sound field encoding format that includes Unreal Ambisonics as one option. Okay, you know, once again, we're getting hit with information that might be relevant to, obviously a sound engineer might know, but
Yes,
you
this would
know,
be more for sound engineering, maybe. When
yeah,
it mentions like a graph, it makes me think of, and how some players you could see the bars going up and down for certain sounds based on what sound was playing. Kind of makes me think of that, maybe. Something similar to
maybe.
that.
I mean, when I hear submix, I think of a mixer, you know, where you can kind of adjust, um, certain heights or certain loudness of, the music coming in or the sound coming in.
Could be that, probably.
Um,
You can see probably the
so
graph and you can alter it, like, okay, this part of the graph needs to be a little lower, maybe this part of the graph needs to be a little bit higher.
yeah, and then you can kind of change like um, the sound wave a little bit to, make, you know, uh, um, like, if you wanted the like a voice actor to be a little bit more robotic, for example, you could probably try to, change the sound file in such a way where it's like, you add a little bit more, or you like change the pitch or something, whatever,
Yeah.
uh, to mess with it or something like that. I don't know if that's this though, because again, I'm not really, when I look at this, they're not giving me that kind of information like you would see a normal mixing board.
No.
Um, so, um, I don't know. I feel like we're getting into a little bit more information that um might be kind of beyond our understanding, and we might get to a point where we're gonna be more confused than anything else. What are you feeling right about now? Shall we go ahead and continue, or are you feeling like maybe we should back out of this?
I'd say that for now we back out of it because this is starting to step into something that's more for sound engineering than anything else.
Yeah,
At least
because I
for
mean
now.
they're pulling out the blueprints and showing like, hey, my ambisonic submix is connecting the output to the input of my resonance submix, and it's like, okay, well, what is, what are these, kind of thing. But they're not really giving you any like, definitive information about it.
Nope.
So, uh, like when we obviously, if we have to get to this point where we need to use this more, um, then obviously we'll need to do a deep dive on it. But
Yeah.
for now, I think we might need to. I think we might also need to kind of back out for now.
For now. Yeah. Like we know
Not to
what
say that,
ambisonic technically is, we just not entirely sure how to apply it ourselves.
yeah, you know, we can kind of get it. It's like right there. It feels like it's like okay, in some ways we're understanding the descriptions that they've kind of given to us a little bit with it already, but um there's just some parts of it where it's like it kind of goes beyond our current understanding, so
Hmm.
we'd have to really kind of do a deep dive on that to make sure that we're like fully comfortable.
Yeah.
So that's all. All right. Shall we move on to sound classes then?
Yeah, let's move on to that.
Okay. Now I see here. right at the very top of sound classes that it is advanced. So we might be once again encountering information that is like beyond our understanding, but you know, we'll see.
There'll probably be a few things that we won't understand. Yeah.
Yeah. So sound classes, an overview of the Unreal Audio Engine sound classes. So we shall proceed. Because we got 25 minutes
Yeah.
left in this hour. We got time
Yeah.
to at least check this out. So, and it is a fairly lengthy topic. But I mean there's also a lot of images and stuff like that. And it looks like a lot of it's kind of just talking about like definitions and stuff like that
For the most part, yeah.
of, of topics. So it feels like it's just kind of going over, what is included in a sound class.
Yeah.
So
And as I believe something we'll probably want to get into a little bit, considering that we did have to make one sound class for like the ambient stuff, for instance.
right, and obviously we're probably going to be needing that for like uh, you know, other features, or other sounds later. Not just ambience, but
Yeah, sound effects or
right,
music
right.
and other
So.
stuff.
A sound class is an asset type for the audio engine within Unreal Engine or Unreal Engine 4 that a user can use to group multiple sounds together. Then alter the parameters of all relevant sound waves at once. Okay. So if like you have, multiple sound waves all kind of combined into one, and you need to say, hey, I need to lower the volume of like everything, you know, like you're traveling away from, you know, a certain scenario or something like that, then you need to kind of reduce down that overall sound, right? Um, so maybe that's what they're kind of going with there a little bit, but.
Mm.
Using sound class mixes, many sound class parameters can be adjusted during gameplay. During gameplay? Interesting. Um, Set up a new sound class, right click from the content browser, then select sounds, classes, and sound class. Right, we've done that. To open the details panel for a sound class, double click the sound class in the content browser. Um, we've done. So general properties. The first set of properties in the sound class are the general properties. So they're showing volume, pitch, low pass filter, frequency, attenuation, distance scale, always play, child classes, and passive sound mix modifiers. Now this probably has been changed, um, on our current, 4.7.
Yeah.
I don't know
I
if it
can I can
has.
always open one of mine and compare it.
We might want to consider doing that actually, just
Opening
to
it.
kind of show, you know, like show the difference because we know, we've already seen some differences already.
But some
Um,
of these, yeah, some of the
you
ordering
know,
might be different.
yeah. So, um,
Okay, let me open my sound class and of course put OBS to show it. There it is. And okay, the general one is still the same, fortunately, by the looks of it. Yeah, the first one, the general one, is still the same. Even the variables are still the same.
okay, hold on. Let me adjust here real quick. we go. And now the details are on the left-hand side, so I'm going to move my over to the right-hand side so everybody can kind of see that. Matter of fact, I think I'll do the same with my webcam. Whee! Okay, okay, so let's see what we got here. We got volume, pitch. Let me open this up a little bit. You got volume, pitch, low pass frequency, filter frequency. Let me
Attenuation, distance scale, always play, child class, and passive sound mix modifier.
Okay, so let's go through each of these, making sure we're good on that. So, volume, a multiplier on the loudness of each sound within the class. So you can have multiple sounds kind of combined in with that one single class. So good to know. This acts on top of volume settings in the sound wave object itself. Okay. So there's that. This acts on top of volume settings. So that's interesting. Doesn't necessarily override, but it you know adds its own multiplier in. So you could technically have like a single multiplier in the sound wave object, but you might have like double the volume or 2 times the volume multiplier for the sound class. So that's interesting. Okay, pitch. A multiplier on the pitch of each sound within the class that acts on top of the pitch settings of the sound wave object. So same as the volume there overall. So now I don't know personally what like the major difference is, like what affects pitch, or what if I personally don't know, like, oh yeah, you're changing the pitch. And I'm like, okay, what exactly does that mean per se? Like, what's happening to the audio, right?
My little understanding of pitch, like, how should I explain this? How the pitch could determine like how deep the voice sounds, or how high the voice sound. I don't know if you heard like those like slowed down songs like that. It pretty much takes its pitch and brings it down to something like the voice sound different.
Let me go ahead and
like I'm talking right now like this. If I raise my pitch, I would sound a little bit like this, and then if I lower it even further down below, I would sound something quite ugly. That would be just me altering my pitch on my throat, pretty much.
Yeah.
So do I sound like a giant's like deep voice, or do I sound like a squeaky mouse? That's from what I little understand of what pitch is technically referring to.
Yeah. I think. Yeah. I mean, yeah. Okay. I'm also taking a look at the um, uh, I just looked up what sound pitch, through Google,
Yeah.
and I am also noticing that um, how many like um, how many waves in like a second kind of thing. Like say like you have 4 waves in a second, right?
Mm.
If you lower the frequency or making it like only 2 waves a second, you're making a lower pitch.
Yeah.
Whereas if you increase the number of waves, meaning that you go from like 4 to say 8, you're you're creating a higher frequency you know or a
Mm.
higher pitch
Yeah.
based off of what I'm seeing here. So um, I think to really solidify that, I'm gonna need to like I'll go online and I'll
Right.
confirm
How
what you
would
were
that
kind of
sound?
going
Like I
with.
said, the higher the pitch, the more like a mouse you will sound. The lower the pitch, the more like Darth Vader you will sound.
Indeed, indeed. Well, I don't I don't know if um we have to be careful with that, okay? Because I don't know if okay, for example, when you're talking about singers, for example, you hear about sopranos, you hear about tenors, you hear about baritones, you hear about basses. Mm, You know, does that you know refer to their specific pitches? Like they always have a certain pitch to their singing voice um that changes what you're hearing, or is it something else that that kind of goes into that? Okay, so we got to be careful with that. I get what you're saying with the changing your pitch. It goes from like high squeak to very low tones kind of thing.
Yeah.
um but
Yeah, if you were to put those sounds through like a sound wave, you would see the difference in the waves.
right, but do you you know so you can modify your pitch along those lines, but I don't know if that has a correlation with like saying that someone is a soprano. Does that mean that they only have a certain pitch that they can sing at? Like they can only do, you know, a certain range of sound waves to achieve that soprano um uh voice? I don't know if that uh it might be like a different topic altogether,
Yeah.
so we got to
Well,
be careful with that.
in the computer running through software, the amount of pitches you have is almost infinite.
Well, yeah, yeah, no, no, I get you on that. But what I'm saying is that we got to be careful with you know we like I don't want to automatically assign like, oh yeah, sopranos, they're just a different pitch. I don't want to make that judgment at this particular point in time, because I don't know if that has the same um, relation with each other or not. You get what I'm saying? Like you can take a soprano's voice and still change their pitch. You can, turn the knob and, change that soprano's, um, high, well, I guess high pitched, sound or singing into something that's very low,
Yeah.
or something along those lines, right?
Yeah.
You can change that, but is that
That's just pretty much what
is
this will do. That's pretty much what this the Unreal is going to do when you alter that.
right?
Like, it won't
But
care what the base pitch is. If you alter that pitch, it'll sound what you as you altered it.
my question though is that should I consider like tenor a pitch? Now my
That
brother
will
would
depend
probably,
on what we're gonna make.
well, my brother might actually answer my question along those lines because he studied music theory, so he probably knows. I mean, he would definitely know more than I would along those lines.
Yeah. I
I
would
mean,
say
he
use
was a
for pitch here in Unreal if we were just thinking in a more practical sense. If we made a character but our voice actor can't hit that pitch, then through Unreal we would edit it and we can get the pitch that we think would fit the character, regardless of how the voice actor sounds.
Well, I mean, hell, if we really wanted to, we can probably make anybody like chipmunks. you know,
I mean, that's what they did with Alvin in the Chipmunks movie.
pretty much. You're not getting, and you're not making them. You know, I mean, today's voice actors might be able to do it themselves. With a certain amount of
Some.
training and stuff like that, they might be able to. But I mean, it's what's the point when you can just modify it through technology, right? You could just have someone just speak regular lines, and then you have the sound editors going, okay, we need to change it up, to Alvin standards, um,
Yeah, there
whatever,
are
right?
very few people that can pull that off of changing their voices. There is this one YouTuber, I can't remember his name right now, but uh, the guys from the Cleveland show actually saw his channel, heard he could change his pitch to sound like Cleveland, and they hired him for that.
hmm but that's the point is that
Like, he can do it himself.
you
He
know
was able to do Cleveland, Trump, Joker.
yeah, some people are able to, but not everybody can.
Yeah.
So
That's why
uh,
most of the time they rely on softwares. So it's not
yeah,
something easy to pull off.
no, no. So um, I mean, like you were saying, the original Alvin and Chipmunks was just just regular voice actors giving those lines, and then they changed uh,
The pitch.
the pitch on those. So, but yeah, I'll have to talk with my brother on that and ask him directly, you know. So, but I'll worry about that later. Okay, low pass filter frequency. The cutoff frequency for a low pass filter that impacts all sounds within the class. A value of 20,000 or above has no effect on the sound wave. Okay, I have no idea what that means.
Not entirely sure either.
What is a low pass filter? What is the cutoff frequency? Obviously, you know, it impacts all sounds. That's great, but you know, what exactly are they?
No, no.
Yeah, so that's that's something that we'll probably need to kind of look into a little bit more because, or we'll need to look into more later just to see like what if um if we want to have some kind of sound uh being affected in some way.
Mm.
Like maybe we want more of like an echo going on or something like that. We're gonna need to study this a little bit more to know like what do we need to change to make the sound, you know, being more of an echo sound than anything else. Like, like, hey, I'm going to clap, but you want it to kind of be, something that sounds as though that it was like inside a cave or something like that, right?
Mm.
Or whatever. So But yeah, it's one of those things where it's like, you know, what exactly are each one of these things doing, and how does it affect that sound wave? That's something that we may need to study more later. Not saying we need to study it now. I'm just saying, like, if we're wanting to get more of a, like, we're we find an audio file and we're like on, okay, well, this is good, but maybe we can create it to be something different for our own purposes. Like, hey, let's say we want to create, you know, like a laser blast or something like that. Like, you know, someone's using a laser gun to shoot, right?
Mm-hmm.
Um, Now, obviously, you know, you have the default laser sounds that are out there and stuff like that, but maybe we want to make a different spin on it or something like that. We want to change it up a little bit, you know. Um, so, you know, we use one of those features to maybe try to improve upon it or something, you know.
Mm.
But you know, obviously, we don't know, you and I don't know a lot about sound engineering to go, oh yeah, you're going to be needing to do this to pull that off, right?
Mm-hmm.
Um, so obviously, you know, as we progress, you know, once again, we may need to put on those hats to basically say, okay, you know, we are we are the sound engineers on
Mm-hmm.
this game, so we will need to, you know, figure out what we need to do to
Mm,
get
yeah.
the right kind of sound that we want for that particular case. Like, like maybe we're trying to play a sound, but it just doesn't sound right. Like maybe it hurts our ears or something like that. It's like maybe too high pitched or something like that. So we need to like lower the pitch, right,
Yeah.
for that particular sound to kind of get what we're looking for. And we may need to play around with it more
Hmm.
to get what we need, um, but yeah, obviously we have no idea what low pass low pass filter frequency is all about. So, but we may need to go back and study that later. Not now, but later. So, uh, attenuation distance scale scales the attenuation distance of each sound within the class, allowing for attenuation settings to be adjusted dynamically. Okay. Uh, what was the definition of attenuation again?
Now we missed with
Attenuation.
attenuation at one point, but with the audio volume.
Um,
No, it was on the sounds within outside the audio volume. It was, I believe.
the reduction of the force, effect, or value of something. The reduction of the amplitude of a signal, electronic current, or other oscillation. So,
I guess in
um,
this case, the attenuation will be the further you are, the less you hear it.
yeah. Well, the sound wave will reduce in size over distance. So, um, so this affects, like, you know, everything, or you know, you know, all the sounds that are associated with said class, you know, it will be affected by this distance equally,
Mm-hmm.
you know. So, which, you know, um, you know, we got to be careful with that a little bit because, like, some sounds might be, um, you know, some sounds might be like louder overall, but again, the attenuation might be it might affect them all equally anyway.
It'll
I mean,
affect whatever
unless you,
we attach this class to.
yeah, I mean, unless there's like a way to have like sound like travel further no matter what, but I haven't really heard about that too much. I mean, obviously, the louder a sound is, the further out you can hear it, right?
Mm-hmm.
Um, but I wonder if there's like something where it's like, hey, you have a sound that will travel farther no matter what. Uh, I, I mean, isn't radio a form of sound? I know of, you know, obviously you have radio waves, but uh, a form of sound. I mean, I'm just kind of curious.
Radio waves is a form of like electrical signal, not sound exactly.
Radio waves differ from sound waves because radio waves are electromagnetic waves and sound waves are mechanical waves. Interesting. Okay.
Hmm. Okay. Yeah, I was kind of curious about that, along those lines, and seeing, obviously they had, similar, I guess you might say, properties in the sense of like, you have, they're both waves in a sense, and you
They're
could
represented in
still,
a similar fashion, but they're not
right,
really the same.
right. So, um, but I wonder, let's see, mechanical waves. Um, what are mechanical waves for dummies? um, some waves can only travel through a material or medium such as air or water. These are called mechanical waves. Sound waves, water waves, seismic waves are all types of mechanical waves. Interesting. Okay. Good to know. I mean, I wasn't, you know, in particular knowledgeable definitively about that, so
Mm.
yeah. Right. Um, yeah. Okay, we move on,
Yep.
shall we?
Yeah.
Okay. Well, we're getting close to the end here, so we'll do the always play here, and then we'll save the child classes for next time, shall we?
Sure.
Okay. So always play when enabled. It prevents sounds within the sound class from being ejected from the voice pool by sounds with a priority lower than always. Wait, what? When enabled, it prevents sounds within the sound class from being ejected from the voice pool by sounds with a priority lower than always. Mm,
I
That's
guess it's in the case that you have like background noise going on and you want another sound effect to play on top of that so that the sound doesn't get interrupted in any way.
it just seems kind of odd that um um
That's how I
like
perceive
you
it.
yeah, it just seems odd to me, like you would have, like if you put like two sounds into the sound class, right? And um one sound has a lower priority, then it just gets removed or ejected in this particular case. That seems a little odd to me that they have that within like the same kind of class. You would think you would think any kind of sound that you add to a sound class would be something that you'd want to obviously be playing like all the time, no matter what. So having a sound being overwritten by another sound within the same sound class doesn't make that much sense to me personally. But I don't know. Just not sure.
I'm not sure either.
Um, maybe there's something that uh, you can do or something like that. Maybe there's something that like there's something there that will allow for you to do that. But it's like, what exactly would that circumstance be? It'd be nice to have like an example of what they're talking about here in this case. Like, what do they mean by having a sound ejecting another sound within the same class? I can understand it, like if you have like a
I guess this will work within the sound class only, probably. Like if you have within the same sound class two different sounds, but one of those sounds needs to constantly be going, none of the children can actually interrupt that sound. I guess this will only apply with sounds within the sound class itself.
well, I'm not sure because I mean this is the um this is the general details. So does it apply to all the sounds associated within the class itself, or does it kind of attach itself to the sound that you are like attaching it towards, like the ambient sounds, for example. You'll always play those ambient sounds. Um,
Yes, that it is just as I thought. I just went into the into my sound class and I created a new sound in it, like a new sound class within it. And the ambient one I put always plays. When I select the new one, always place is not selected. So this will affect whatever is inside the sound class itself.
Only affects what's inside the sound class, not necessarily the sound file or the ambient sound.
No. Like if you look at the image like below, you got those two sound example sound classes. They both have their own respective general. They don't share the same one. That's when I saw when I added one on mine. I already deleted it, but like if I select the first example one, I put always play. Then I select the second example child class. That child cannot interrupt the first one. If I don't select the always play, then the child will interrupt the first sound class.
Okay, interesting. Okay. Well, we'll have to cover more of this tomorrow. Or
Yeah.
actually, no, not tomorrow.
No,
Tomorrow's your day off.
tomorrow for the
Uh,
time is my day off.
yeah. And Thursday might be a day off for me because it's United States uh, Thanksgiving.
Right, right.
So
Yeah, so I won't schedule for Thursday.
yeah, so I might be out on Thursday myself, like
Mm,
completely.
Don't worry about it.
So
I would just want to schedule anything that day for Unreal.
yeah, so just
Yeah, no problem.
giving you a little giving you a heads up on that one.
Yep.
Uh, Obviously, if things change, then I'll let you know. But uh, I have a penciled in engagement right at this moment in time.
Yeah, no problem there.
I have so uh, so I might not be, you know, able to stream on
Yeah,
that
yeah.
day. So um, but yeah, I think that's gonna be it for today. So let's go ahead and like close on out, and then you go get yourself something to eat. I'll upload some videos on my end, and then we'll play some Terraria later on tonight.
Yep.
So, okay?
Right.
Bye, man.
Alright.
You have yourself a good time. See you in a little bit.
See you in a little bit.
Talk to you later.
Bye.
Bye.
Okay, I'm out of the stage. Just let me lower a few things. And okay, I'm pretty sure that's what I understood from the always place. After I put like a second one in there, I could see that they don't share the same general details. So I'm pretty sure I understood that correctly. So right now I'm off to get something to eat real quick, and before jumping into some Terraria Calamity mod later today, like in roughly speaking an hour or so. And this sound class is something that we will probably have to learn quite well, since we're probably gonna end up using sound class a lot when we start making a game. The Ambisonic one, that one was a difficult one. There was like several things that we couldn't understand. If anyone actually understand the stuff that we were looking earlier on the Ambisonic, then leave it down in the comments below. Maybe explain it to us a little better what it was actually referring to, the orders of it, what exactly the channels is actually referring to, the difference between Fuma and Napsik. Leave it down in the comments below, and on the next video I'll mention it about it, and also give you a little shout out as a thank you for whatever other information that you provide us. Because like we said, we are mainly programmers, we're not sound specialists. We don't have anyone to help us with regards of sound. That's why we are trying to learn this stuff. So until we can find someone that can help us with sound when we come to making a project, then that would be great. We won't have to worry so much about it. But right now we have no choice. We have to learn as much as we can about this stuff. So thank you all for watching. I hope you enjoyed this little segment of Unreal. And I'll hope to see you all in a little bit for some Terraria. Bye bye!